Hey guys, so here's the second set of questions for that constant acceleration review sheet we were working on. So let's just jump right into it. A car starts from rest and accelerates uniformly over a time of 5.21 seconds for a distance of 110 meters. You need to find the acceleration here. So you have that special word, a car starts from rest, so you know that your initial is going to be 0. And it's accelerating uniformly over a time of 5.21 seconds, so that's RT is 5.21. All right, and a distance of 110 meters, so that's going to be RD, right, or our change. And determine the acceleration. So acceleration is our unknown. So which equation fits the mold here? That's our D equals VIT plus 1/2 AT squared. So we have a distance of 110 meters. We have an initial velocity of 0, time of 5.21, plus 1/2 A, that's our unknown, and then T squared, 5.21 squared. So we're going to get 110 meters equals, what's this double equals? All right, 0 plus, now we're going to do 5.21 squared and then multiply it by half, and that should give us 13.57 times A. So I'm just going to get 110 is equal to 13.57 A. Now I need to get A by itself, so I'm going to divide each side by 13.57. And in the end, I'm going to get A is equal to 110 divided by 13.57, which is 8.1. This is an acceleration, so that's meters per second squared. All right, let's just jump right into the next one. So we'll grab a new file. Let me copy the question. All right, here we go. So on this next one, engineer is designing the runway of an airport. Right. For planes that will use the airport, the lowest acceleration rate is likely to be this 3 meters per second squared. The takeoff speed for planes is about 65 meters per second, and we need to assume that all of the planes have the minimum acceleration because we need to design the runway at least for the slowest planes. And what's the minimum allowed length of runway? So what can we get away with here? So since we're talking about planes that are going to be accelerating, it's safe to assume that they're going to start from 0. All right, we have an acceleration of the slowest planes, and that's going to be 3 meters per second squared. We know that planes need to reach at least the speed of 65 meters per second, so that's our final, all right, or they won't be able to take off. And we're looking for distance here, so that's our unknown. So in this case, which equation deals with these 4 variables? That's going to be our VF squared equals VI squared plus 2AD. All right, our VF, that's 65. Our VI is 0 plus 2 times A times D, our unknown. So 65 squared, that's 4,225. And believe me, guys, I'm not doing this stuff in my head. I definitely did it beforehand, so I know all the calculations here. 2 times 3, that one I can do in my head. So get D by itself. We've got to divide each side by 6. And then we're going to get, as a final answer, that D is equal to 704.2. And that's a distance, so that's meters. All right, let's move into our last one now. So in this last question, we're dealing with something that goes up and then something that comes back down. So in order to deal with these questions, what we want to do is we want to think about them in 2 pieces. We want to think about the up piece first, and then we can figure out the down piece. Right? Because we know something special about someone that's jumping. We know something that particularly happens right here at the top of their jump. And we know that the velocity at the top is going to be 0. So we can use this information to help us find one extra variable to figure out which equation to use. So if Michael Jordan has a vertical leap of 1.29 meters, that means he can jump up 1.29 meters. So that's going to be our distance, right, or our displacement. And what is his takeoff speed and his hang time? So in this question, we need to figure out two different things. We need a takeoff speed first, and then a hang time. So how much time is he in the air for? So how much time up and how much time down together. All right. So the first piece is we're going to figure out what is his takeoff speed. So what is the initial velocity that Michael Jordan is jumping off of the ground with? What velocity is he getting right there? So in this first part, the VI, that's going to be our unknown. Now, since we're only going to look at this halfway, right, we know up here at the peak of his jump, his velocity is going to be 0. So we know that his final velocity is going to be 0. And since this is on Earth, we know that acceleration is 9.8 meters per second squared. But in this case, it's going to be negative 9.8. Because in this case, the acceleration is in the opposite direction of his initial velocity, because his initial velocity is going to be up, right? It's going to be a positive number. He's going to jump up with some kind of velocity, and acceleration is going to be acting against that, right? It's going to be in the opposite direction. That's why it's negative in this case. So which equation deals with these four variables? That's going to be our VF squared equals VI squared plus 2AD. All right, our VF squared, we know that's going to be 0. Our VI squared, that's unknown. We put the squared there anyway. Times 2 times A, which is negative 9.8. And times D, which is that 1.29. So 0 squared is still 0. VI squared, that's our unknown. If I multiply these numbers together, I'm going to get negative 25.28. So this is all going to be a negative 25.284. All right, so I can really get rid of this plus sign right here because this is a negative. So it's like VI squared minus 25.28. So a couple things I can do. I can bring the VI over to this side of the equation, or I can just bring this 25 over. So I think that's what I'm going to do. I'm going to add 25.284 to each side of my equation. So that way it cancels on this side, and I'm left with 25.284 is equal to VI squared. So from here I can take the square root of each side, and I'll get that his initial velocity is equal to 5.03. It's the velocity, so this is meters per second. So now that I know his initial velocity, now I can figure out time. I can do this two ways. I can figure out how much time it takes him to reach the peak, and that'll be his time up. And then I can multiply that by 2 because it'll be his time up plus his time down. Or I could figure out the whole question. So I could figure out his time up and down all at once. But I think what I'm going to do is I'm just going to figure out his time from jump to peak height, and then I'm going to take that time and multiply it by 2. So now that I have an initial velocity, I can use one of my equations that deals with time. So in part 2, I'm going to use my VF equals VI plus AT. Maybe I'll put a border right here. So my final velocity, that's going to be the 0, right? Because that's his velocity at his peak of his jump, which is always 0. His initial velocity was 5.03 meters per second, right? And that's plus, now this is a negative 9.8 still, times t. All right. So what I'm going to do now is I'm going to add this to both sides in order to turn it positive and get it to the other side of the equation. So I'm going to add 9.8t to both sides. It'll cancel on my right hand side, And now I'll be left with 9.8 t is equal to 5.03. I can get t by itself by dividing each side by 9.8. And then I'll be left with t is equal to 1.03. This is a time, so this is seconds. All right. And you guys can see that if you punch the numbers in the calculator yourself, they may be a little bit off. I rounded to the nearest hundredth in all of these cases. All right, guys? So I hope this helps. You guys can study this stuff on your own. And until next time.